Okay, guys, so today we're going to look at Unit 3, Independent Task 2, okay? So you should have already had a go at the 5 questions. Here were the topics we had. So we had modulus functions, arcs and sectors, transformations of functions, binomial expansion, and then arithmetic series, okay? So you should have already had a go at this and then got onto a certain level of support. Remember what we said before. If you're getting down to like the level 3 or the level 4 support, so you're speaking to a friend or you're asking your teacher or someone in the maths department for help, you need to then consider the fact that that is a topic that requires a good amount of work. Okay, it needs a lot of work from you independently on top of it. Okay, so what we're going to do is we're going to go over each question. So for question 1, I've set up some axes. Could you do some sketching? And the first question says, I want to sketch y equals the modulus of x minus 2a, where a is a positive constant. So we don't know what it is, but we need to think about how it's going to go. Show the coordinates where the points of the points where the graphs meet the axes. That's the y-axis and the x-axis. So that's what I'm going to calculate first. So to do it on the y-axis, I'm going to do it when x is 0. I'm going to sort of substitute x is 0 in. If I substitute x is 0 into my equation, I get the modulus of minus 2a. Remember, if we take the modulus, that'll make it a positive. So I'm going to get the positive 2a. So it's going to cross somewhere about here at 2a. Okay, I don't know what a is, but I can say it's going to be roughly at that height. Now I'm going to also do the x-axis, which means I'm going to do it when y is 0. If I do that, I get 0 equals the modulus of x minus 2a. Now, normally we now take the modulus, we do the plus and minus of the other side. So we look at the positive and negative version, but obviously it equals 0. So it's only ever going to equal 0. So that's the same as me saying x minus 2a. Okay, and if I solve that, I get x equals 2a. So again, it's going to touch my axis at 2a. Okay, now generally in a modulus function like this, we should have that kind of V shape going on. Okay, if I consider what this equation looks like, so x minus 2a, and I thought about this as on a set of axes, this would have a gradient of 1, so it would be going up, and then it would cross at minus 2, so it would go down to minus 2 down to here, and I would have a straight line that looks something like this. Now, obviously, what we know is that when we hit the x-axis, like here on my little green dot now, okay, it almost bounces back up and comes up into its place. So it's going to look like this. I'm going to draw that a little bit better. So I've got my line going up that side, and I'm going to have my line going up this side. Obviously, we should be doing it with a ruler. And that's my graph there. That is my y equals x minus 2a. The modulus of x minus 2a. Now it says use algebra, so I'm going to use my algebra to solve the following. So I've got x, the mod of x minus 2a equals a third of x. This is where we're going to use the positive and negative. So the first one I'm going to look at is, let's say, x minus 2a equals the positive version. And then I'm going to look at the other version where I've got x minus 2a equals the negative version. Okay, and I'm going to solve these accordingly. So I'm going to take my x's to one side, I'm going to take my algebra to the other. So if I take this x over, I get 2/3 of x is 2a. And if I solve that for x, I will get 3a. If I do the same for this side, I'm going to add a third, so I get 4/3. So I get 4/3x is 2a. And again, I'm going to rearrange to solve that. That's going to give me x is 3/2a is my answer. So there's my two answers. Now, obviously, probably what's thrown quite a few people off with this is the fact that we've got a's involved. Just work with it like normal. Okay, it told me it was a positive constant, so I can just use it like a normal fraction, or sorry, normal number. So for the last one, we got on a separate diagram, sketch the graph for this function here. So I'm going to write it down here. I've got y equals a minus the x of mod, so mod of x minus 2a modulus, okay? So that's the equation I want to sketch. And again, it wants to know, show the coordinates where the points on the graph cut the axes. So again, I'm going to do the same thing I did before. So I'm firstly going to do, okay, what happens when x is 0? Okay, so when x is 0, I've got a minus the modulus of minus 2a. Again, if I do the mod of the inside, that's going to give me a minus 2a. So it's going to cross on the minus a. So it's going to cross all the way down here. Let's say that minus a is there, okay, for the sake of argument. I'm going to do the same again, but I'm going to do it when y is 0. So when y is 0, I get 0 equals a minus the mod of x minus 2a. Okay, I need to solve this. So the first thing, I'm going to get the modulus on this O, so I'm going to move it over to the left-hand side. And I'm going to do what I did in question 1. I'm going to look at the positive and negative versions. So that's x minus 2a equals a, or it's x minus 2a equals minus a. And I'm going to solve these. So the first one, if I solve it, it's going to give me 3a. And the second one, if I solve it, if I add on 2, is just going to give me a. So it's going to cross 2 points. It's going to cross at a by here, and it's going to cross at 3a by here. Now, if we compare this to our first function, okay, we notice we got the same modulus, but I've got a negative in front of it. That's, remember, if I put a negative in front of my function, that's going to flip it along the x-axis. Then I'm going to add a, so it's going to jump up a. So I'm going to have my end result. This should be halfway, so let's go about there. I'm going to go through my points like so. I'm going to end up with a upside down v like so. Okay, there's my end function. That is what this is going to look like. Okay, what I've done, okay, is I've flipped this one up here along the x-axis, and I've jumped it all up a, so I've added a onto all of it. Right, so for the next one, question 2, we've got arcs and sectors, okay? So some key bits here, okay, we've got this shaded bits, we've got a major and a minor. The major would be the shaded bit, and the minor would be this non-shaded bit down the bottom, okay? So it tells me it has a radius of 6. So let's put a 6 centimeters on here so I know what I'm dealing with. Points A and B are on the circumference of the circle, and it tells me the area of the shaded major sector, so the area of this sector here, is 80 centimeters squared. Given that AOB, so A to O to B, so that could either be this blue angle or this orange angle. But it does tell me where it's between 0 and pi. Now, 0 and pi is between 0 and 180, so that means it has to be the smaller one. So this one would be theta. Calculate the value of theta, and then I want to calculate the length of the minor arc. So the first thing I need to do is I need to do theta. Now, the issue is obviously I don't know much about this minor arc, but I do know about the major arc. But I can work out what this orange angle is. A full turn would be 2 pi. So I'm going to have 2 pi minus theta. Okay, so I formed a little equation there. Now, I did do the area here. So I've got area, this pi, is equal to 80 centimeters squared. Now, if I use my formula, okay, which we should know, it's a half r squared theta, okay, for the area. So I've got a half times r squared, which would be 6 squared, times by theta, which in this case, we're talking about the orange one, is going to be 2 pi minus theta. Okay, now I know everything in that line. I'm going to just take my time with my solving, okay? So if I rearrange it and I get just my 2 pi minus theta on its own, so I get rid of everything else, I end up with 40 over 9. There we go. And I'm going to rearrange it with theta, so I'm going to do 2 pi minus this, gives me 1.839 radians. Okay, then we've got to make sure we're in radians. That's why I'm dealing with 2 pi, and I'm not dealing with 360. So for the next one, I want to calculate in centimeters, correct, due to decimal places, the minor arc. So I'm looking at this arc here, this green arc here. So we should know the arc length is r theta. Okay, the radius is 6, and we just calculated what theta was. Theta is 1.839. I'm simply going to type in my calculator. It's nice and easy to find arc length when we know our formula. So I've got 11.03 centimeters, correct, 2 decimal places. It's a nice easy one, but we do need to be comfortable with working backwards and dealing with a full turn at the same time. Okay, so topic 3, we've got transformation functions. So given that f of x is log f, so this one hasn't been drawn for me, I may have to draw it myself. Sketch on the diagram the graphs for y equals f of x, so I need to draw this one, and this function here, so y equals 2/3 f of x plus 4. Label the coordinates of the points of intersection on each of the graphs with the x-axis. So make sure you read the question. I only want to know where it crosses the x-axis, and indicate the behavior of each graph for large possible values and negative values of y, because that's just going to be shown on my diagram. So the first thing I'm going to plot is I'm going to plot my f of x, okay, which they told me is log x. Now this is a graph that we should know, okay? Log x, let me do my x and y. Okay, should cross the x-axis at 1. Okay, and then should come down like this. And we should have an asymptote. Okay, so it should never actually touch the y-axis. And then it's going to come up like so. I kind of round off a little bit now. I'm going to draw that a little bit better, but that's the kind of shape that we're looking at doing here. Okay, so I'm going to come up, I'm going to hit 1, and I'm going to keep going like so. That is my y equals f of x. Okay, and I'm going to consider what's going to happen now with my new function, which is y is 2/3 f of x plus 4. Okay, so just remember what happens. If it's outside the bracket, it affects the y coordinates. If it's inside the bracket, it corresponds to the x coordinates. Okay, so first of all, this 2/3, I don't really have any y coordinates to deal with, but if I want 2/3 of it, I'm going to do 2/3 times the y coordinates. Okay, which means all my coordinates are going to be lower down, so this graph is going to be less steep. Okay, so it's not going to be as steep as this line when I get up to the top. It's going to kind of plateau off a little bit quicker. Okay, inside the bracket, I got plus 4. Okay, which means I'm going to take away 4 from the x coordinates. Okay, which helps me quite a lot because at the moment I've got asymptote on the y-axis. I've got an asymptote down here on this y-axis. You can't see it very well, okay, because obviously it's there. Now, if I take away 4 from that, it's going to have a new asymptote by here at minus 4. Okay, so that's a new line it's not going to touch. The other coordinate that's going to change is this 1. Okay, I'm going to take away 4 from it. It's going to get me to minus 3. So it's now going to cross at minus 3. Okay, apart from that, it's going to take the same shape. As I said, it's going to be less steep because I don't really have any y coordinates to deal with. Okay, as I get to here, it's going to plateau off a little bit quicker. Okay, so that's my new green function there. Okay, now that is me showing what happens as I get to it. If I drew it and it went above my y equals f of x up here, I'd be incorrect. I'd be losing marks. I'm not taking into account the fact that my line is less steep than the previous one. So we got 2 more questions. Next question, we've got binomial expansion. So the binomial expansion for, I'm going to write out 1 plus 9x to the power of 2 over 3. In ascending powers of x up to including the terms of x cubed is this. So they tell me what it is, where mod x is less than a ninth. So they told me what it's valued for. Calculate the values of c and d. So they haven't told me the coefficients of x squared and x cubed. Now, realistically, I could isolate those and look at them independently, but probably the easiest way for me to do it is to just do the full expansion, okay, like we normally do. Okay, so the first bit is 1, okay, plus n, so 2/3, x, which is a ninth, so 9x. Sorry, 9x is my x here. Plus, I'm just using the formula from my booklet here, n, which will be 2/3, n minus 1, so 2/3 minus 1, all over 2 factorial, so 1 times 2, so 2 factorial, times by 9x all squared. Okay, now the next bit isn't in your form booklets, but it is one that we should know. Okay, so I've got 2/3, then I've got 2/3 minus 1, then I'm going to have 2/3 minus 2. That's all going to be over 3 factorial. And I'm going to have 9x all cubed. Okay, and then plus dot, dot, dot. Okay, now I'm just basically going to simplify this out a little bit. So I've got 1. If I times these 2, I get 6x, which is what they've got here, which works out perfectly. The next bit, I'm going to type all this in. So I'm going to type in the fraction, and I'm going to times it by 9 squared. Okay, that gives me minus 9. So let me get rid of that plus there, because it's a minus. Minus 9x squared. Okay, then I'm going to type all this in and times it by 9 cubed, and that's going to give me plus 36x cubed plus dot, dot, dot. If you want to do it in more than that one step, that's fine. It's safer if you are doing it like that. Okay, so therefore C must be minus 9 and D must be 36. Okay, so now I've got my expansion. Use this expansion and with your answers for C and D with the appropriate value of x to obtain this here. So I want to try and find 1.45 to the 2/3. Okay, now so what that means I need to do is I need to try and make that bracket. So I need to try and make 1 plus 9x equal 1.45. So I need to try and find out what the value of x is I need. So I can solve this now. I can take away 1. That's 0.45 and divide by 9. So that means x is going to have to be 0.05. So what allows me to do is substitute that in. So when I say that, I can go 1.45 to the power of 2 over 3 is approximately, because I'm not going to use all the expansion because I haven't done it all, 1 plus 6 times 0.05 minus 9 and then 0.05 squared plus 36 and then 0.05 cubed. And what I'm going to do is I'm going to type that all into my calculator. And it comes out as 1.282 to 3 decimal places. So the final part, what it wants me to do is compare. So it says obtain 1.45 to the power of 2/3 from your calculator. So if I do that in my calculator, I get 1.28108713. That's the answer I get. And hence make a comment on the accuracy of the estimate. So you see these are really, really close. Now I've got to decide how close are they, okay? So you notice they're the same up until the second decimal place. That's what I'm going to write at, okay? So I'm going to write the approximation, the approx is correct to 2 decimal places. That's what it's looking for me to do. That's the point at which if I rounded it, they would still be the same. That's it correct to 2 decimal places. Final question, we've got arithmetic series. Kyle is making some pattern from out of squares. He has made the 3 so far, so here. So straight away I see this, and I think, okay, I'm going to change this to numbers. So row 1 is 3. The next row I've got 5, and the next row I've got 7. So part A, it simply wants me to find an expression in terms of n for the number of squares required to make a similar arrangement for the nth row. So I basically just want the nth term. Okay, now I'm going up in 2, so I've got 2n, and I add 1 every time onto that, so it's 2n plus 1. Now I have got an AP here, I'm adding every time. Now if I'm thinking about an AP in general, I need to know what A is. A is 3, and D would be 2. So I'm going to need that later on if I need so. Okay, so the next one, Kyle counts the number of squares he used to make a pattern in the kth row. He used 301 squares. Write down the value of k. So I know that 301 equals 2n plus 1. And I'm simply going to solve that for n. Okay, n would have to be 150 in that case. So it's not n, is it? It's k. So let me change that for a k. So I'm looking at the 150th term if he's doing that. Right, the final bit, I'm going to start to use my equations a little bit more. The first q rows, Carl uses a total of p squares. So that's a sum of, I'm talking about all the rows combined. Okay, so if I'm using the sum of q, okay, it wants me to show this. So I'm using the sum of q. I know that if I use my equation for my formula bucket, q over 2 times 2a, so 2 times 3, plus n minus 1, so q minus 1, times by d, which is 2 in this case. Okay, and that's saying that this sum equals p. Okay, so I'm basically just going to rearrange and solve this equation now. So I've got q over 2, and then my brackets, I've got 6. Then I'm going to span it by 2, so 2q minus 2, and that equals p. And again, I'm going to keep rearranging and solving. So I've got q over 2, and then I've got 4 plus 2q, and that's p. I'm going to expand out, so I've got 2q plus q squared equals p, and I can rearrange that. That is q squared plus 2q minus p equals 0. So that's part 1. That's what they wanted me to get there. For part 2, they tell me, given that p is greater than 1520, find the minimum value in the row. Okay, so if p is greater than 1520, okay? Then this must be greater. So I've got q squared minus 2q, or plus 2q, minus 1,520 should also be bigger than 0. I'm going to solve it, okay? I'm going to factorize and solve from here. Okay, if I factorize it, I get q minus 38, and I get q, make that look like q, plus 40. So I get q is 38, or q is minus 40. And again, if I think carefully here, okay, we're talking about q represents the number of rows. Now q, that means q can't be a negative number. Okay, so the minimum number of rows. So let's go back. There should be an inequality. So that means q should be bigger than 38. Okay, so therefore minimum number of rows, minimum number of rows should be 39. Okay, not 38. I'm still talking about an inequality, so be careful when we're solving at that point. Okay, so apart from that, make sure you've marked all of your work and you've taught about the level of support that you need, and then go over any topics that you need to now. But apart from that, I'll see you in the next video. Thank you, guys.